Hello and welcome to the version 10 release training for the ForecastBuilder software. There are several changes in the release, and here are some of the highlights. The first is user look and feel. We've had a few changes to this, but the main one here is expanding and contracting a toolbar on the left side, which helps denote where you are in the process. And I'll show you an image on that in a little bit. We've also incorporated some concepts learned from Central Region and Southern Region when working with the MBM precipitation types. Back in version 9, we have lost the auto-run functionality, and that has been restored with version 10. A frequent request has been the ability to add some local procedures and tools to the finalize step, and so we've added that ability. Something that's been happening over time is that regions have been populating QPF from WPC Guide, so that has been added to version 10 as the default. An issue that has happened here several times during the fall and spring is that the snow amount would have a jagged appearance, and a lot of this is due to a variety of criteria which I'll show later in the presentation, and we've helped clean that up in this release. There's been some updates to the snow level consistency check, and you'll see that here later in the presentation. And we've also applied a variety of technical bug fixes and improvements, as we do with all releases. This release in particular, I want to give some credit to Matt Belk from the Norton office. We've got some of his suggestions in. And we've also incorporated a few fixes to the embedded hourly T from min-max T tool that was incorporated with or built into version 9. And one of which includes the hourly temperature updating outside the time range. And you may ask, why does that happen? And well, one of the things that can happen when you run this tool is that outside the time range that you've highlighted, you get this dramatic jump. And you notice that, like, say you do a today grid, which is like a 12Z to 0Z, but your min T grid or max T grid may overlap outside that time range. And so when a consistency check runs later, that grid is going to get changed, and we don't want that to happen. And so this hourly T from min-max T tool will go outside the time range and make sure that you have a consistent flow of temperature going from day to night. So a little more on precipitation type. So the MBM P-type approach has been overhauled again, incorporating lessons learned from Central Region and Southern Region. We've also made it compatible with the snow level methodology. Now, from the lessons learned, the MBM P-type approach now requires an extra step to be completed, which is an unconditional precipitation type step. And that's fine. This also allows forecasters to have total control of the weather types, at least those that are precipitating, while ensuring consistency with their foundation grids. We've given a whole training video module devoted to the MBM precipitation type approach, so please view that for more information. So other than the consistency changes with snow level, all the other precipitation type methods remain unchanged, that being top-down and Burgoyne. So let's talk about the user look and feel changes to the GUIs. So here's the new GUI here with version 10, and immediately you'll see that toolbar to the left. Again, it expands and collapses and allows you to jump to any step. And here on the right, you can see what that toolbar looks like when you expand it. So we've given little icons to each step, and when you mouse over it, it'll expand to this list. You can also right-click on any of these steps on the toolbar to set it in skip, auto-run, or to-be-run mode. Again, that auto-run was that one that we lost from version 9. And each of these color code too. So you can actually see where you are in the process, if any of them are set to auto-run, and if any one of them are inconsistent. I should note that with back to the auto-run that you can configure the software for the office to auto-run a certain step too, and that's documented in the configuration instructions. Additionally, here at the bottom of the GUI, you have your Run Continue button, which in this case shows green, and that's saying, hey, that's the next one that you need to run. There are also navigation buttons here to bring you to the previous step or go to the next step. And then, of course, the exit ForecastBuilder, which has been there for a while. Regarding the snow amount in shoulder season, so ForecastBuilder here has had two checks to zero out the snow amount. They have been the surface wet bulb greater than 33.5 and the temperature greater than 35. These checks together would result in sharp, jagged snow amount. We fixed this in version 10 by only using the wet bulb greater than 33.5. That makes it match what we have in the MBM, and employs a slope from 33.5 to 35. So let's do a little before and after to show you that reflection here. So here's a before image, and you kind of see you've got these very sharp edges here going from like 2 inches or so to absolutely nothing, or in the case there's one grid pixel or a couple grid pixels that are above 8 inches that go to absolutely nothing around it. So here's the after, and you see the snow amount getting quite a bit spread out. So this is an example from Salt Lake City's area, and all these snow amount pixels are all in terrain, sharp terrain that is even. And again, as I noted, that you have these sharp differences from grid point to grid point, and it gets a little bit more smoothed out, and that smoothed out is just from employing that small little slope there from 33.5 to 35 in the surface wet bulb. So that should resolve this issue for everyone, and any of those grid points here in the after image are all having like snow, some part of snow mentioned in the actual weather grid forecast. I want to do a little review on this topic about max apparent temperature. And we had some issues here during the course of the summer months asking about why is my max apparent temperature higher than any of the hourly T's of apparent temperature. So in version 9, max apparent temperature was calculated using the max T and the RH at the time of highest hourly T. Let me focus on that RH part, because in version 10, we switched that RH to dew point. So we're just scanning the dew point grids now instead of the RH grids. It does make a small reduction, but it's not, it's not a big, massive overhaul. Ultimately, the root cause of the max apparent temperature being too high is related to the MBM. The MBM max T is calculated independently from the hourly T. Similarly, min T is calculated independently from hourly T. So those grids, max and min T, can be several degrees higher, say than the maximum hourly T, or in the case of min T, lower than the minimum of hourly T. So just be aware of that. We've made some improvements here. The MBM side is also monitoring this. All right, let's talk about the snow level calculation process. First, a little review. Here's the diagram that we've shown for several releases here at ForecastBuilder, but it really is nice and clean and tells you what's going on with the snow level process. So you go with all snow all the way up until about a 0.5 degree C wet bulb. For about an 800-foot zone from that snow level down, you're going to get this mixed rain and snow zone, which you get applied 100% to both your probabilities for snow and rain. And then once you get to beyond 800 feet down from the snow level, you get to all rain. But we do have some consistency checks in here, just because of the nature of the way a snow level grid may interact with your topography, resolution, and all. Should your surface wet bulb exceed 2.5 degrees centigrade, we're going to make that all rain. If the surface temperature is below freezing, we're going to set that as a mix for rain snow. But there are some new tools in here in the Analyze Adjust step that allow the forecaster to find these areas that have been highlighted here as consistency checks and make adjustments to T or snow level to remove any inconsistencies. There's also a gross error check here versus temperature. If the surface temperature is greater than or equal to 55, that one's going to be set to all rain. Some other notes here: the snow accumulation gradually decreases as you go below the snow level, so that way you don't end up with any jagged things like described earlier, where we did that little work on the surface wet bulb stuff. And then freeze and rain, the only way you can get this in the snow level process is to include a prob ice present grid with a value of 0. Or any value essentially less than 100 will get you some freeze and rain introduced. So let's talk about these consistency check changes. So in ForecastBuilder version 9, we had this snow level consistency button. Well, here in version 10, you see a whole bunch more of different items here to choose from for buttons. And I do want to preface that this example shown here for both version 9 and version 10 is when NBM and snow level are your precipitation type approaches. So the snow level and T consistency check again has been moved to this new snow level section with now flags or which flags grids and shows inconsistent pixels. The offending grids will get colored white, and that's going to reflect where the snow level is below the ground when the surface wet bulb is too warm. And you'll get a pink color to the grids where snow level is above the ground but the temperature is below freezing, and that would be implying a freeze and rain forecast. Again, we've added some additional snow level consistency tools. These are listed here. Change temperature to match snow level, change snow level to match temperature, the pouts from snow level, which is a step that only appears if working with NBM probably weather types. We've also added some snow amount consistency tools, such as find where the surface wet bulb reduces snow amount, and where to lower T to ensure no snow amount is reduced. I would like to refer you to the NBM P-type methodology training for more details on all of the tools and the consistency check mentioned here. So the path forward here with ForecastBuilder. The past several releases have had many user impacts, and we recognize that. There's been GUI changes, inclusion of tropical, NBM as a precipitation type approach, and how that process works. So as we go forward here, we kind of want to slow down a little bit here on the variety of changes that impact you, the user, and shift mainly to behind the scenes with future releases. Some examples, there are some updates that are needed to the blow and snow code, and those have already begun, and we just need to get those in to release. They weren't making it in here for version 10. We'll get that probably in a 10.1 release. There's some additional checks here that we could make probably to the NBM precipitation type approach. You know, continue to improve the technical side on this, go through and do some more code cleanup. And then finally, can we include some probabilistic data into the process? Again, how we do that is still unknown, but that's just something that we're looking forward to here for the future. So that's it for the version 10 overview training. If you have any questions or would like to post any feedback, again, the ForecastBuilder NWS chat room exists. You can also go to the ForecastBuilder virtual lab site, which will get an update here quite a bit with version 10. And you can also just email us. The email address there, nws.forecastbuilder@noaa.gov. Thank you very much for listening. And again, let us know if you have any questions. Thank you.